My name is Alec, and I'm incredibly passionate about both math and computer science. Today, I wanted to showcase some of the projects I spent this past year working on. I first researched stochastic calculus, a branch of math that directly dealt with the randomness of stocks. I was able to chalk it down to a formula that dealt with the volatility, the drift, the time period, and the random sample of a stock. I used PyTorch, Python's designated library for machine learning. As you can see, due to these very low loss values, the solution actually did work very well. I heavily enjoyed this project because I believe it really shows how you can bridge both math and computer science, and how computer science is almost a catalyst for math, and the things you can't do by hand. Like for example here, the thousands of operations, the calculus operations that a neural network must do, which you can't really do on pen and paper. But aside from financial mathematics, I'm also heavily interested in many physics concepts, and have two projects that I feel really demonstrate my interest in this subject area. My first project is an nBody simulation, which is a simulation meant to demonstrate the gravitational force of thousands of celestial objects all acting on each other. I first modeled this in WebGL, but I did this naively, which meant I produced a runtime of O of n squared, which meant that I basically had two nested for loops running and checking each object and each object on each other, which is really slow, so I could only simulate so many objects, so I had to opt for another solution. So I decided to use the data structure of a quad tree, which produces a runtime of O of n log of n, which is a lot faster. During the process of implementing the quad tree, I learned both OpenGL and low-level C++, which are two skills that I both believe are very fun, will also serve to be very useful to me in the future when I want to do future modeling in computer science and math. And this brings me to my final project, which was a ray tracer. While I was designing my nBody simulation, I was working with lighting and learning lighting and the vertex shader and fragment shader and OpenGL and all of that stuff. My friend told me about ray tracing, which I thought was ingenious, so I decided to create my own. My main research entailed both linear algebra and fundamental graphics principles that I both combined to create a ray tracer that accounted for reflections, transmissions, and emissive lighting, which all was done probabilistically. Though I hope to improve on this in the future, and I have some ideas of how I can do this probabilistically depending on the material. I felt that this project was a little less fundamental to my understanding and overall just more fun and interesting in general, especially because I felt that a lot of the preparatory understanding of math and computer science was already completed with the first two projects. So this was my portfolio video. I hope you enjoyed watching it, and I also will provide links to my GitHub if you are interested in seeing any of the code at all. So yeah, thank you.